Nuclear fusion. In this video, we're going to understand how two or more nucleons merge or fuse together to create something more powerful and meaningful. So let's start by talking about the word nuclear fusion. Nuclear means the process which involves the nucleus, and fusion in English means two or more entities coming together or merging together to form one single entity. So, nuclear fusion can simply be defined as the fusion or combination of nuclei. Scientifically, nuclear fusion can be defined as a nuclear reaction in which lighter nuclei are combined together to form heavier product nuclei with the release of enormous amounts of energy. For example, lighter nuclei such as lithium and helium, when combined together, form a heavier nucleus. The mass of the heavier nucleus is less than the initial reacting nuclei. The word heavier here is phrased in terms of energy release, which is usually very enormous rather than mass. Therefore, the law of conservation of energy is satisfied. Consider the example of two hydrogen nuclei combining to form deuterium. Here, one hydrogen atom combines with another hydrogen atom, giving deuterium, one positron and one neutrino. This deuterium, in turn, combines with another hydrogen nucleus to form a helium isotope. If two such helium isotopes are fused together, the formation of heavier helium takes place. These three steps of a nuclear process, where 4 protons are fused together to form the heavier helium-4 nucleus and enormous amount of energy, is a nuclear fusion reaction. The chemical equation for this nuclear fusion is as follows. 4 hydrogen nuclei, when fused together, give rise to the heavier helium. But how is this enormous amount of energy being liberated from such a seemingly simple nuclear reaction? To understand this, let's first calculate the loss of mass in the process. The starting mass of the 4 protons is 4 times 1.0078, which is equal to 4.0312 AMU. But the final mass of a helium nucleus is 4.001506 AMU. Therefore, the loss of mass is 4.0312 minus 4.001506, which is equal to 0.0297 AMU. This is equivalent to the energy given by Q is equal to 0.0297 AMU times 900 mega electron volts per AMU, which is equal to 27.67 mega electron volts. Wow, that is a significant energy release coming from the fusion of the 4 protons. However, in spite of such a substantial amount of energy being released in the nuclear fusion reaction, there are no full-time nuclear reactors built so far for fusion reactions, as it is very hard to control such enormous energy release.